All right, well, those of you who are using schema stitching, I'm going to give you another workout because I'm curious. Like, put your hands up if you're running schema stitching in production. And keep your hands up if you're really happy with your schema stitching solution. All right. Well, good. Most of you guys are in the right talk, because today we're talking about stitching to federation. I'm going to talk about a few things there. First of all, I want to tell you a little bit about how we did schema stitching at Apollo, what we got out of it, what some complaints were that we had. I want to talk a little bit about the federation architecture, how it solves those, and what the architectural differences actually are. And then I want to give a set of simple steps that we followed internally to migrate our infrastructure in place and incrementally. And finally, I want to finish up with some learnings that we had from running in production for the past few months. So I should probably start by introducing myself, though Jesse did a little bit of that for me already. My name is Adam. I lead the infrastructure team at Apollo. And Apollo's infrastructure is all of the cloud APIs that support our own graph manager. And this is everything from cluster orchestration to our metrics pipeline. And specifically, all of this supports our own distributed data graph, built at this point with stitching. And since May of 2018, we've been running a schema stitching layer, which gave us a lot of benefits. We got to take advantage of different runtimes, right? The rich JavaScript ecosystem around GraphQL was fantastic for building out a registry service. And similarly, the complicated nuances that we needed to dig into our metrics pipeline in order to merge together results, it was great to have Kotlin running on top of the JVM for that. We also got to work on these two different code bases separately with different teams. We could bring in people from the platform team to work more closely with us on the TypeScript code base because that was a language that they were familiar with. But there was a major problem, which is that stitching required us to have a lot of custom code in our gateway. And not only did it have a lot of custom code in the gateway for business logic and linking logic, but additionally, it caused us to reconfigure all of the obvious gateway problems, to resolve the idea of handling just basically sending context from the gateway to the underlying services. Things that you don't need to deal with when you're running with a monolith, but you absolutely need to think about when you're running a gateway. And if you haven't seen principled GraphQL, one of the first principles that you'll see is one graph. And as someone who cares a lot about user experience, and someone who thinks about the data graph, I love the concept of one graph, because organizing all of Apollo's data into just one graph makes sense for our users, makes sense for our clients. But as an infrastructure engineer, it terrifies me, because that's a single point of failure. And one thing that I know about single points of failure in critical infrastructure is that they should have one job, they should do it really well, and they should not really change very often. I want to be able to treat my gateway, that single point of failure that delegates down to underlying services, as a standard Docker image that does what it thinks it should do. So with that in mind, how does the architecture of federation support the needs that we have for a gateway? Well, first of all, it's declaratively just GraphQL. That gives some benefits I'm going to talk about in a moment. But second of all, it really just has three components that have well-defined responsibilities. Services are responsible for all of the business logic, as well as declaring dependencies on other services. That's not something that we have in our gateway anymore. And the gateway is responsible for planning queries and transporting them to services. The third bit is having a graph manager, some way of managing the dynamic configuration of that gateway. Because the gateway needs to have knowledge of what the underlying services are in order to effectively plan queries and send transports. And that shouldn't be something that happens within the gateway. That should be something separate. So now the crux of this is, how did we actually make this switch to federation? Well, the first thing we took advantage of is that the changes necessary for the services are actually all just backwards compatible schema additions. That meant that we could move them incrementally and in place. We could migrate service by service, field by field. And specifically, we didn't have to make massive overhauls to our service layer. We did need to stand up new infrastructure, like a gateway and a graph manager, but we didn't need to have all new services running in place. So we had 4 steps. Well, the 4th one is kind of migrate, but 3 steps. Starting off, just adding federation support to the services, making sure that they implement the federation spec. The second one is standing up the core infrastructure that needs to be there to make sure that you can run federation. That means having a federated gateway and having a graph manager that configures it dynamically with its underlying services. And the third step is actually implementing the linking logic, all of those links between types of different services that used to exist in our stitching gateway, and putting those into the underlying services. And finally, migrate the traffic. And I'm going to go through all of these steps one by one. If you miss any of them, you can go to this link here. It's all in our public docs. And I'll throw those up later on and throughout the talk as I reference things that you might want to dig into a little bit more for your own migration. So step 1, adding federation support. This essentially adds the implementation of the federation spec to the services. And it looks a little something like this. It has, as I mentioned before, we have 2 services that we run. One of them is in Kotlin. The other one is in TypeScript on Node and the JVM. And the Kotlin code is a line. TypeScript code is a few lines with a whole bunch of new lines. And it essentially wraps around our schemas and our resolvers to implement the federation spec. Now, there's implementations for this in a number of other runtime libraries. That's also available in those docs for you to see if it supports yours. And there are new community contributions coming all the time to do this. We were really happy we were able to do this in our 2 languages without needing to do much additional than those few lines. Which brings me to step 2, actually standing up the infrastructure we need to run federation in production, having a gateway that can talk to the underlying services and a graph manager that configures them. So the first part, standing up a gateway, thankfully was very, very thin. There's not a lot of configuration. In fact, in our case, there's no configuration that we needed for the gateway. The gateway needs to understand how to talk to the underlying services. But as far as being configured as to which services to talk to and what their state is, that's something that the graph manager is going to come in and do. And for running the server, we just plugged it into Apollo server and ran it. As far as setting up a graph manager, I've talked about this a few times. We actually thought on the infrastructure team that managing the configuration of the gateway is something that should never happen inside of the gateway. That's just a concern it doesn't need to have. It would clutter up the set of concerns and make it a little bit heavier than it needed to be, less reliable. And so we thought it was so important that we built it into our product, and we made it available completely for free in Apollo Graph Manager. Whether you use Apollo Graph Manager or you build your own, we think that this is a solution you need in order to run federation in production. And why is that? Well, one of those things I mentioned before is just separating out the concerns of the gateway. The gateway doesn't need to be in charge of dynamic configuration. But the other one is actually separating out the service runtime and the service uptime from the gateway uptime. Your gateway shouldn't go down if services make a breaking change. If someone pushes a configuration that doesn't compose, your gateway should still be resilient to that. So what we did at Apollo, we built this by making a service registry. So under a graph, there's a set of services, and each of those services has metadata about it. That's its partial schema, so its dependencies and the contract that it has in the GraphQL layer. A location, in our case, this was a URL for the gateway to go call those services. And a revision, a service version, to track for observability reasons, so we can understand when we're running operations, which service version is it running against. Maybe you didn't change any part of the contract, but you did change the resolver logic. And we would, every time that we pushed into the registry, we also wanted to have safety as part of our own graph manager. And the way that we did this was specifically that if you were to push a change, only composed changes would make their way to updating the gateway's dynamic config. This allowed us to work on services in isolation that might be making simultaneous changes that are incompatible without having that propagate to 500s for all of our users. If it does compose, then the graph manager will go ahead and write out a configuration that the gateway dynamically picks up, and it smoothly rolls over new traffic. making sure that any new queries that come in are planned with the new configuration, and any in-flight requests are properly resolved. So once we've set up the graph manager and the gateway, we've set up our ability to push services into, in our case, a service registry, and that updates the gateway automatically. What we have is a managed gateway, and it's actually enough to query. We have our underlying services. We wrap them to give them federation support. And we can probably get into those root fields in each of those services, but we don't have any of the linking logic yet between the two. We didn't actually move that from the stitching gateway yet. So all we can do is talk to each service kind of as a proxy. But this is a great checkpoint where we were as we were migrating to make sure that we could actually still get to the underlying services, that we'd set everything up as we expected, and that updates were propagated as we made changes to those root fields. But the next step, the important one, as far as the business logic goes, because this is where the user's concerns are most critical, was moving the linking logic from the stitching gateway to the federation gateway. And it was really important to us to migrate incrementally. We didn't want to have an interruption to service. So we actually wanted to run both of them at the same time, above the same services, so that we could continue to develop on those services, add product features inside of them. So we did this by just duplicating that resolver logic that was already in the stitching gateway and putting it in the underlying services where it needed to go. And the one extra thing we needed to do is anywhere where we had additional SDL in the stitching gateway, we just took it out, because now that was in the service layer itself. When the gateway was configured with the services partial schema and its contract, it would get that type extension that was previously in the stitching gateway. So what does this look like? Pretty much the same. In fact, exactly the same. Your business logic shouldn't be changing here. Your resolvers are still doing the same thing. The model with federation and schema stitching actually is very similar from a resolver standpoint, which is that your source is the type that you're extending and all of the fields that you're acquiring on it. The only difference is that rather than dynamically declaring a fragment to query in order to use as part of your parent, you're going to specify that in an at-requires directive. You're going to specify that within the SDL itself of the service. And once we've moved that resolver logic, we also need to, as I mentioned before, take out the additional SDL that we put inside of the stitching gateway. This will make sure that the stitching gateway doesn't have a type collision when it runs. So once we have moved all of the linking logic, or even if we've only moved some of the linking logic, we can start migrating traffic. In our case, we had a number of different resolvers, and it was easy to abstract all of them into functions, move them all at once. If you have a lot of different linking logic inside of these resolvers, you can move them over one by one and migrate traffic specifically that hit those fields as well. I understand that every single organization is going to have different requirements about migrating. There's going to have different requirements about what their operation load is, how many different services there are, how many different types. That might affect your decision, as well as the extent of client usage. So I'll talk about the process that we took internally, but however you migrate traffic is going to be up to you. One thing that we did was we ran the federation gateway and the stitching gateway actually in the same exact node process. This made it really easy for us to shift based on context, which one we were looking at, whether we wanted to switch by user or by client, to look at the federation gateway or to look at the stitching gateway. And we moved first all of our testing frameworks. We duplicated them, making sure that they could execute against both of the gateways. Then we moved over users, internal users, as guinea pigs so that we could check and see that everything worked. Then we ramped up clients and then all of our traffic in staging and production. So now we're completely on federation, 100%. We've been there for 3 months. And the question is, what comes next? The first thing is we cleaned up a ton of stuff. We were able to entirely delete the stitching gateway. All of the vestigial root fields that we had on our schema, we were able to remove. Because of the way that schema stitching worked, we ended up having a lot of fields that were only really there to support foreign keys, and we could just take them out. And finally, we could take this sigh of relief that our gateway was thinner, that we were able to have a more reliable single point of entry into our data graph. But we also got some improvements out of the box just from setting it up, comparing between the two. The first was an observability improvement, getting federated tracing out of the box that had an understanding of every single time that the gateway was making a query, what was the set of fetches it was making to underlying services, and in each of those services, a field-by-field level heuristic of its timing data, as well as error data. Being able to look at errors and correspond them back to the underlying services has been a huge observability win. The second bit was a clear answer on how to customize transports to actually share context. This was something that we needed to do with stitching, but we were kind of just doing it however we felt like it. And there wasn't a clear and obvious answer for how to do it. One nice part about federation is that there was a clear answer for sharing context. It was the idea of having a data source that you will plug in as you build your service. So you can specify this by service. You can do it in general. What we did is for all of our services, setting some additional metadata that we could always assume would be there in the underlying services. Now, this had benefits to us because it means we don't need to deploy our gateway as we add new services in. But if you have something that's service specific, this is where that would go as well. And lastly, I mentioned this before, having just a much more focused gateway layer. The gateway is responsible for planning queries and sending transports. It's not responsible for managing dynamic configuration. It's not responsible for implementing business logic. This actually allowed us to remove more than 1,200 lines of TypeScript, and that's not even including all of the resolvers. That's just stuff to set up stitching in the first place. And we have a much cleaner gateway now with the idea that it creates a server, has some config. Most of this is rate limits and things like that. Some context, which there's not very much in, just where to proxy. Because our gateway is responsible as well, not only for it's responsible not only for being a gateway, but also for proxying for webhooks and things like that, as well as some helpers for observability, like never sending out variable values that could be sensitive personal information. And the last thing we got was having static validation on our services. All of the different services can be developed in isolation, but we still wanted to make sure that they're not stepping on each other's toes and violating the dependencies, making the gateway not compose. So the idea is that the idea with service validation is you can point a proposal into the registry to understand what's going to happen. And in the usual case, this will work as schema validation will, just checking against breaking changes. But in the other case, oh, I missed my slide. I don't know how to get this to play. Oh, there we go. But in the other case where composition fails, you'll end up seeing what those errors are, and it'll fail service validation as well. So having that level of validation on all of our PRs has made sure that we don't ship breaking changes onto master. Now, they won't get to the gateway anyway, but having them in our code base is bad enough. So finally, after we took all these improvements, we also had some learnings that we had at the end of the day. So we've been thinking about composing GraphQL schemas for a long time, and but that doesn't mean that the industry has all of the answers as to everything that we're going to run into. We're going to figure out a lot of these things as we go. Running a distributed API is not a new problem, but running a distributed API with GraphQL is still relatively young. These are some of the things that we've learned so far. First thing is you should really treat query planner changes with the same amount of gravity as you would a database migration. Changing the primary key on an entity might have effects of touching every single service that other services are dependent on. Additionally, you don't want to expose implementing services. Having an invariant that all of the traffic goes through the gateway is extremely valuable, and it might also be a security concern to even expose those implementing services. The third one is that having a graph manager for running in production is absolutely necessary for our reliability. But when running tests or when running locally, having a static service list makes a lot more sense. It allows us to mock out the other services that might be dependent on for our local development workflows. And that looks something like this. Starting up a gateway, checking an environment variable to see if it's cloud, otherwise having a static service list that runs. And I'm hoping that coming away from all of this, you guys have a better idea of what it means to migrate from whatever architecture you have, whether stitching, monolithic, or otherwise, to a federated architecture, as well as some idea of what the benefits are that come with it and the things to watch out for. I want to thank all of you for just hearing my story and listening to my spiel, and thank you for your time. And I'm happy to, as I walk around in the hallway, if you have any questions about all this stuff, I'm really excited to see as this progresses.